Hi guys, welcome to Lytical Preps. So today we are going to learn about trigonometry. Okay, trigonometry. I'm going to learn the basics and solve this problem. So our problem is to solve a ladder leans against a wall. The end of the ladder touches the wall 12 centimeters from the ground. The foot of the ladder is 9 centimeters away from the foot of the wall. 1. What is the length of the ladder? 2. Calculate the angle the ladder makes with the ground. So this is a typical application of trigonometry. Now, maybe trigonometry is your first time of hearing this. Okay, this is your first time of hearing trigonometry. So trigonometry is all about shapes and angles, the relationship between shapes and angles. Okay, angles. Good. So we normally use right angle triangle in our calculations. Right angle triangle. So a right angle triangle is like this. Good. So this a right angle triangle. The reason why we call this a right angle triangle is that it's having a 90 degrees angle within. So there's it. So when we indicate it like this, it means that this portion is made up of what? 90 degrees. Good. Okay. So this right angle triangle here, we can name the side. Okay. With this 90 degrees, we can call it right angle. Okay. When you say right angle, it means 90 degrees. Those that you do technical drawing, you know what I'm talking about. Good. And we can also call it 90 degrees. So all the same. Now we can only name one side of this triangle. So we can name this side, the longest side, which is straight opposite to the 90 degrees. We call it hypotenuse. Okay. So let's represent it by H rather. So let's make it H. So which is the hypotenuse. Okay. Now we can name these two sides when we okay, so we can name the two parts, okay, when we indicate the given angle, okay, when we are able to indicate an angle. So let's say we have been able to indicate a given angle here, say theta. Now we will be able to name the rest. So now you can see that our angle given here, theta, is facing this length or this side. So we call it opposite, okay? Opposite side. So we can represent by O. Okay, opposite. Now you can see that the 90 degrees, which is this, is facing the given angle, the theta. Okay, or you can see that the theta and the 90 degrees, they all lies on the same side. That's the length on the same line. So we call it adjacent. Okay, so we call it adjacent. So let's take A to represent adjacent. So now we have been able to name the sides with a given angle, say theta. So this is our hypotenuse, this is our opposite, and this is our adjacent. Now let's try this and see. Good. So this is a right angle triangle. Indicated nicely like this. Like I said, we can only name one side for now. So let's say this is our A and this will be our B. Now, I drew this because in mathematics, you won't always get one way things, okay? This one is different. So I drew this because we may not always see right angle triangle like this. Okay, that's mathematics for you. So let us now try to name this right angle triangle. If you have gotten this, like I said, the length which is straight opposite, directly opposite to the 90 degrees, we call it what? Hypotenuse. And don't forget, we can't name any other side again because we haven't been able to indicate any given angle. Okay, we haven't. So assuming we indicate this side, let's say theta. So we indicate this side as our theta. You can see that this is different from this, even with the angle located. You can see that? Good. So now we can name the other sides aside the hypotenuse. Now we can say that the side which is opposite direct to the given angle that we name it theta is called opposite. So we represent it by O. We can now also name the other side. So you can see, like I said, the given angle and the right angle triangle, they are facing each other and they are lying on the same line. You see this length. Okay, so let's say this will be our adjacent side A. Okay, so A. Now there's it. So we are going to use this right angle triangle to bring the formula called okay, so we are going to use right angle triangle to develop the Pythagoras theorem, okay? To develop the Pythagoras theorem. So let's see, this is our side A, B, and C. Now, Pythagoras and his students, that's a philosopher, they sat down and analyzed this. You can see that when you are at C, okay, you can move straight to A. Good. And also, when you are at A, you can move from B, then from B to C, or you can move from A straight towards C. So they sat down and said, oh, okay, so going around this from here to here is the same from A to C. Then they work and prove whether it is correct or wrong. So they sat down and said that the side which is AC, so AC squared, since we are saying that moving from A to C is equal or the same as moving from A to B and B to C, okay, so we should equate it and see whether it's correct. So we say that AB, so AB squared plus BC squared. Good. And they did, and everything was correct. So Pythagoras, we are having length AC squared, which is equal to AB squared plus BC squared. We called it Pythagoras theorem. Okay, so this becomes our Pythagoras theorem. Yes, so we had AC squared, which is equal to AB squared plus BC squared. So in words, you can say that the longer side squared is equal to the squared or the summation squared of the two other sides. Okay, good. Now, we are continuing with this. You can see that the side AOH, that is adjacent, opposite, and hypotenuse. Okay, we have another way of calculating the sides, which brings to us as the sine ratios. Okay, now aside Pythagoras theorem, we have a way of calculating the length also. That's what we call it trig ratios. Okay, the trig ratios. So let's look at these trig ratios. So basically, we have 6 trig ratios. But for now, I'm going to introduce only 3 for you. Then our next lessons, I will add the 3. So I'm going to introduce the first one, which is the sine. The sine, we call it, there's the spelling, the sine. What is this sine? So we say that the sine, when you take this right angle triangle and we talk about sine, it means that it is opposite over hypotenuse. Okay, opposite over hypotenuse. So this is our opposite and this is our hypotenuse. Okay, so assuming with this our angle given, okay, with this our angle given, if you want to get the formula to calculate the angle, okay, assume you will be given the hypotenuse and the opposite. We say that sine theta is equal to our opposite is O over what? Our hypotenuse. Okay. Then the second one, we talk of cos. Cos. So the cos 2, with this angle here, the theta, we say that cos theta. Okay. These two, we can use two sides, which is the adjacent and the hypotenuse. So we say that cos theta is equal to adjacent over hypotenuse. Okay. Now, the last one, which is the tangent. Okay, the tangent. So we call it tan. And this one too says that tan theta is equal to, now the tan is opposite over adjacent. So we call tan theta now becomes opposite over adjacent. So let us try to form something here. You can see that our sine, we can say it is SOH. Okay, so the S means sine, and the sine represents what? Opposite over hypotenuse. See that? Then let's come here. We can this one too. We can get CAH. Then the tan, it says TOA. I believe you know what I'm forming. Good. Some already know this. So let us try to add all this alphabet. So we had SOH, we had CAH, we had TOA. So we can say that SOHCAHTOA. So you can memorize these 3 trigonometry ratios in a simple way. So SOHCAHTOA, like that. of which so is sine and is opposite over hypotenuse. Cos, adjacent over hypotenuse. Toa, which is tan and is opposite over adjacent. Simply like that. Good. I hope you are enjoying the lesson. Let us come to the main question problem so that we use what we have done so far to solve this question. Okay? Good. So now, the problem of the day and tackle it. So, a ladder leans against a wall. The end of the ladder touches the wall 12 centimeters from the ground. The foot of the ladder is 9 centimeters away from the foot of the wall. 1. What is the length of the ladder? 2. Calculate the angle the ladder makes with the ground. Good. It's a nice question. So let us start. You know, one secret is that in trigonometric application, we try to draw or sketch something down. You visualize the question and you sketch it down. This will aid you to solve the question correctly. Okay? So let us try that. So the ladder, as usual, in a wall. A ladder against a wall. So we can say that this should be our wall. Like this. So let's say the wall. Then, definitely a wall will get a ground. Good. So let's say this the ground. It's left with our ladder. So get the ladder. So nice like this. Good. Good. So we are getting a ladder leans against a wall. So you see, sketch it like this nicely. The end of the ladder touches the wall. So this is it. This is the end. It touches the wall. 12 centimeters. 12 centimeters from the ground. So you see, when you measure the wall from the ground, this is the ground, don't forget where the ladder touches the wall is what? 12 centimeters. Good. Then continues, the foot of the ladder is 9 centimeters. The foot of the ladder is 9 centimeters away from the foot of the wall. So this is the foot of the wall, and this is the foot of the what? The ladder. So from the wall to the foot of the ladder, they said it's what? 9 centimeters. So you get 9 centimeters. So it was 9 centimeters. Now, what else do we need? It says, what is the length of the ladder? So the question is asking us the length of this ladder. Okay, and we don't know. We don't know. So we can say that let x is equal to length of the ladder. Good. So we can name this as our x. Okay. And what else? Calculate the angle the ladder makes with ground. Oh, okay. So this way it makes with the wall, and this way it makes with the ground. Okay. So we are talking about this side. Okay. So let's call it theta. Good. So this is how our sketch would look like. Okay, this is how our sketch will look like. Now let's start to calculate it. Look at this very careful. you can see that it is similar to right angle triangle. Don't forget that the wall and the land, it forms what? A 90 degrees angle. You see, a right angle triangle that we are getting. So the wall against the ground. So assuming that this is the wall and this is the ground, you see, it is perpendicular to the ground. So here will be 90 and here too will be 90. So this is how our sketch looks. So we can say that this is a right angle triangle. So we can use the procedure to solve what we learned to solve. Okay, good. So we can use our Pythagoras theorem to get the x, right? Because moving from the top of the wall to the ground is the same like moving from this side to this, right? Good. Or you can say that this be our A, B, and C. Okay, so moving from A to C is the same as moving from moving from A to B is the same as moving from A to C and to B. You see, good. So you can say that by using Pythagoras theorem, our x, which is the longer side, okay, the longer side. So our x squared is equal to the two shorter side. So we get 9 squared plus 12 squared. So we have to sum up our left hand side. So we have to, okay, so we have to simplify the right hand side. Okay. So we are getting x squared, which is equal to 9 squared is 81. 12 squared is 144. So we get x squared, which is equal to 81 plus 144. We are getting 225. Now, what do? We have to take square root of both sides. Okay. So taking square root of both sides, we get our x to be root of 225. And root of 225 is what? Is 15. So we get our x to be 15. Don't forget that our x now is 15 centimeters. So coming from the length, so that's the length. Yes, that's the length of the letter. That's the length of the letter. So our question 2, it says that we should calculate the angle the letter makes with the what? With the ground. Good. So in this case, this side becomes our adjacent, which is 9 centimeters, and this becomes our opposite, which is 12 centimeters, and our hypotenuse is what? 15 centimeters. So we can use these trig ratios. Okay, we can use these trig ratios. One of them, in fact, all of them, we have the answers for them. We have the opposite, we have the hypotenuse, we have the adjacent. So we can use any of the trig ratios, but we need to use one. So in this case, we can use sine, we can use cos, but I would prefer using tan. Okay, good. So you can say that tan, the angle given was what? Theta. Tan theta is equal to, we know that it's equal to opposite over adjacent. Okay, So we get tan theta. We don't know our theta. That's what we are looking for. Opposite is 12. So you can write 12 there over our adjacent is 9. Good. So now we have to make the theta the subjects. Theta the subjects. But don't forget, in trigonometry, if you want to make theta the subject, we say inverse. Okay? Inverse. So you can get sine inverse, tan inverse. So you can see that sine theta, if you want to make theta the subject, we get sine inverse. So you can get theta is equal to sine inverse. So assuming that sine theta is equal to A, so let me use this O over H. So our theta now becomes sine inverse of O over H. Okay, like this. Then cos theta, it was A over H. When you want to make theta the subject from cos, you say that theta is equal to cos inverse of A over H. Likewise, the tan. So it's tan theta, which is O over A. So it becomes theta is equal to tan inverse of O over A. Don't forget, okay, so theta is equal to tan inverse of O over A. Don't forget that our alphabet here represents the expression that we are going to get, the terms, okay? Like this. See, so our O is the 12 and our A is the 9. So let us make theta the subject here. So now we get theta is equal to tan inverse. Now our O is what? Is 12. Our A is 9 over 9. So you take your calculator, then you punch inverse. So your calculus, the inverse is the shift there. So you punch shift, then tan. You see it there. Good. So after that, we are getting theta to be 53 degrees. Okay, so this is the nearest whole number. So we get theta to be 53 degrees. So our solution, final solution, the length of the lever is, it was 15 centimeters. So we had 15 centimeters. And the angle, the leather makes with the ground is 53 degrees. Thank you for watching. Hope you enjoyed the lesson. Please don't forget to subscribe and hit the notification button so that any update you'll be the first to get. Thank you.